We'll give everyone just a couple more minutes as I see some people still trickling in. So we'll get started here in just a couple minutes. Thank you again for joining us. Yeah, absolutely. Thank you guys. And
All right. Looks like um, mostly everyone is in here, so we're going to go ahead and get started. So hello, everyone. Thank you for joining One Tech's webinar this afternoon on Edge AI, the future of innovation. Today, we'll be discussing the significance of AI moving from the cloud to the edge, the unique benefits that this innovation delivers to organizations, as well as cover a couple of use cases around how companies are deploying and applying this AI today. So as a quick introduction of our speakers today, my name is Michael Robledo. I am on the marketing team here at One Tech, and I'll be your host for today's session. And I'm also joined by Abraham Guo, a data analyst for One Tech, as well as Chris Catterton, the Director of Solutions Engineering here at One Tech. And so as a quick overview of the agenda we have laid out for today, we'll be covering a few different main topics around the landscape of the current or the current landscape of AI and the business value that AI is delivering currently to companies across the globe. Then we'll take a look at the current world and how AI is tying in around the industry trends and executive priorities that are arising around current challenges. And then from there, I will hand it off to Abraham, who's going to do a deeper dive around Edge AI specifically, and do a detailed comparison between cloud and Edge AI. And then Chris will close us out with an overview of how where MicroAI fits in within the Edge AI space, and cover again those use cases around how it's being deployed and applied currently. And then at the end, we will be opening up for a Q&A session. So again, feel free to submit any questions within the chat as they arise throughout the session, and we will address as many as we can during the Q&A. So just as a quick overview, if this is the first time you're hearing of One Tech, just as a quick overview of what we do and who we are, we're an artificial intelligence company based out of Dallas, Texas. We deploy industrial IoT solutions across the globe. We work with a wide array of companies, ranging from large agriculture and automotive companies to telco providers to industrial manufacturers and OEMs. And we deploy our Edge AI powered solutions with a core mission to optimize asset performance while enhancing privacy and security. And so now we're going to take a quick look at the AI landscape in today's current world. So as I'm sure many of you may already be familiar with, AI can be simply defined as the human intelligence or the study of human intelligence in a computable way. And while artificial intelligence is certainly not a new term, with the field being founded back in 1956 at a conference at Dartmouth College, AI has certainly come a long way since then. And so today we typically see AI deployed in the cloud. And the reason for this is these sophisticated algorithms require a massive amount of computing power to process vast amounts of data that's being generated every second of every day. So the first example that I've included below to really highlight how AI is impacting virtually all major industries and how it's being applied within those use cases. I want to take a look at Nissan, which is really more of an industrial example. So Nissan has been deploying AI across their manufacturing operations to reduce operations costs and risk and downtime associated with maintenance. And so by deploying AI across their operations, they've enabled predictive maintenance capabilities and in turn have delivered on that reduction in downtime and costs related to maintenance. And so the next two examples are more so focused within the consumer space. Spotify and Amazon, as I'm sure many of you are familiar with, they leverage AI for enhancing consumer experiences within their platforms. So Spotify leverages an AI algorithm to deliver these enhanced consumer experiences through tailored playlists, really learning the preferences that their listeners have, whether that be genre, when they listen, how they listen, and really tailoring the music that's being generated targeted directly to them. And Amazon leverages AI in arguably one of the most popular examples of AI today, which is their virtual assistant, Alexa. And so NVIDIA, as the final example, is actually an example of how AI is being used to enhance various user experiences across the gaming industry. And one interesting study that they actually conducted recently was they deployed an AI model that was trained and it was able to rebuild a Pac-Man game from scratch without any human intervention. And so just while these are very high level examples, this is a way for us to paint a picture and highlight really the value that AI is delivering to these organizations and industries across the globe. And so now that we've taken a look at what the AI landscape looks like currently, we'll do a quick overview of kind of how this ties into our current world. So with our world becoming more connected every single day, it's resulting in a data overload for a lot of enterprises. And this data overload is a result of the rapidly growing number of data sources ranging from multiple IT systems to IoT deployments and a growing number of mobile data sources that produce vast amounts of data every second of every day. And this is making it challenging for companies to basically generate these critical insights from the data that they're needed to make these critical business decisions. And so this is highlighting a growing need for AI to be leveraged as a tool to process all of this data efficiently to generate those critical insights. And additionally, with those data sources growing daily, it's also leading to a growth in security vulnerabilities that are susceptible to smarter attacks. Think, something like the 0-day attack that happened a couple years ago. And so with AI being leveraged not only as a tool to process this data efficiently, it's also a tool that can be leveraged to deliver enhanced security for these data sources and counterbalance that growing number of vulnerabilities. And so, really understanding where AI fits into that the current world today, it's time for us to take a look at kind of really understanding the business value of AI. So with AI being an effective solution for companies to use to combat that data overload, really understanding the value that it's delivering and where it's delivering the value is essential. So at a high level, Gartner estimates that AI augmentation will create $2.9 trillion in business value and 6.2 billion hours of worker productivity by 2021. And the advantages that deploying AI in your operations delivers can vary from use case to use case, and it's very dependent based on its applications. So deploying AI within an industrial setting for for purposes, aligned to those industrial applications. Some advantages that this AI delivers is improved worker safety, improved OEE or overall equipment effectiveness, and a notable reduction in maintenance and operations costs. And within a more consumer-focused market, AI is delivering value to organizations using it around, better understanding the consumer behavior and market trends to adjust and adapt and make those critical decisions when time is of the most importance. And some other notable advantages that AI delivers to these organizations is enhanced database security, reduction in cloud computing costs, enhanced hardware security, as well as data processing automation. And so now I'm going to hand it off to Abraham, who's going to discuss, why AI is moving to the edge and what these unique advantages are that this innovation delivers, and then do a comparison of cloud AI versus edge AI.
Thank you very much, Michael. My name is Abraham. I'm the data analyst of OneTech. My primary focus is on IoT security with the edge AI. I configured and developed some components of MicroAI. I'll talk about the cloud versus edge, the difference between cloud AI and edge AI. First, let's talk about cloud AI. Cloud AI is primarily the default AI when we talk about AI nowadays. A few years back, there was a huge breakthrough of computing power. As Michael mentioned earlier, the cloud-based AI use a lot of computational power to train and build a model. This computation power enables the AI to really learn through the data set. But also this is a benefit for cloud AI. You can use as much as computational power you want. I believe a few days ago, OpenAI announced some of their APIs. One of their model was trained on 100,000 different machines on the cloud. But this also can be a drawback for the cloud-based AI. For a lot of industry uses, this cloud, the cost of the cloud is really, really expensive, especially when you want to train a lot of data. Even though the cloud allows you to grow, to easily grow, but the cost, high maintenance, and computational cost prevents a lot of business from adopting the cloud AI solution. And also the cloud AI requires some expertise in the AI field, requires like much more expertise in the AI field. You have to have somebody who are really, really familiar with the structure of AI, the algorithms and everything in order to build the AI model. A huge concern for the cloud-based AI is that your data is not fully under your control. Your data transferred across the cloud and stored on the cloud. There are huge privacy and security concerns. For example, the Amazon Echo has been known to monitor every single conversation that you have. This inevitably going to cause issue in the future. So what is the edge AI? What is the edge? Edge is the term that originally used to describe the devices that provides network access for the endpoint. Examples of edge devices are routers, switches, and modems. But nowadays, because the edge device allows endpoint devices to connect to the network, nowadays we use the term edge in a more generic term just to refers to all the IoT devices and devices at the endpoint. The AI at the edge allows modern solutions for modern enterprises. It can solve a lot of deployment hurdles that cloud AI could not easily solve. It reduces the cost on the cloud resource and the maintenance on the cloud resource. It doesn't mean you have to completely eliminate cloud, but it significantly reduced the cost of maintaining a cloud. It also reduced data latency. If you deploy your AI next to your data source, the data goes to the AI engine instantaneously. There's little to no latency at all. For some applications, this is very important. And because all the data is at the endpoint, your data is very secure and is fully under your control. I'll give you a few examples of how edge AI can be used. For example, a lot of the factories, they have robotic arms on the assembly line that are doing the same job every single day over and over again. Those robotic arms need regular maintenance to make sure the work they do are very, very accurate. If you deploy edge AI on those robotic arms, you can monitor the behavior and monitor a lot of data through the sensors, and then with the AI, you can predict at what point you need to maintain your robotic arm. Normally, for those kind of machineries, the factory, they have a certain set of intervals where you, let's say after 6 months of usage, you have to replace some parts or change the oil or something like that. But with MicroAI, with MicroAI deployed, the AI will learn the behavior pattern of your machines and tell you at what point you should actually do the maintenance. It can prolong the life of your machinery and tell you to do preventive maintenance before an actual breakdown happens. It saves money on both maintenance and prevention of breakdown. Another important example is the IoT security. IoT devices nowadays, they really have very primitive security designs. A lot of the companies, if you read the news, the Mirai attack and all of that, a lot of the companies, they think Linux systems or Unix system in general cannot be hacked, and they put almost non-existent security measures on their devices. This is not true. It's not true that Linux operating system cannot be hacked. It definitely can be hacked. But the challenge on IoT security is that the computational power is not a lot. The IoT device doesn't have a huge, strong CPU in the device. So if you go the traditional route, keep scanning the whole system, you really don't leave a lot of the computation power for your actual job. With edge AI solution, where we do not approach the security solution with the traditional solution where we constantly scan your system and you have to regularly update a database of signatures. We don't do none of that. The AI analyze your behavior, and whenever there is a abnormal behavior happens, send you an alarm. With this kind of security design, you don't have to, like the AI will provide you the same level of security without needing you to constantly updating your database. You just leave it there, let the AI run. It's for the next 10 years, you have the same level of security. It can prevent you from unknown attacks. Now, what's the benefit of edge AI? Like I mentioned before, the edge AI can give you real-time data, reduce the data latency, and significantly lower the cloud computing cost. You don't have to eliminate cloud. You can, feed your data to a cloud-based dashboard, which is much, much cheaper than training your model on the cloud. It can also provide a faster deployments. The edge-based AI, especially for our micro AI, are not as complex to deploy compared with cloud-based AIs. Those cloud-based AIs often have many steps to model your data, collect your data, and trim your data, pre-processing, a lot of processes, and a lot of trainings on the training. The training takes very long time, and it cannot be done with one training. One training, you might realize your model is not correct. You need to tweak this thing here and that thing there. You have to train it again, and that's another few days training to a few hours training to a few days. Sometimes can take months. And also, edge AI can potentially be more accurate and precise because the AI is deployed near the data source at the endpoint. You can feed better quality data to your AI engine. There are some typical challenges to edge AI. At this current moment, the biggest challenge is that a lot of the edge device, they use highly trimmed Linux operating systems. Their hardware and operating systems are not universal. So that kind of prevents a faster deployment for edge devices for AI. This problem can be solved by using micro Docker containers and putting more libraries on the operating system. And another challenge could be potentially that if a company doesn't have enough expertise in the domain field, in the domain area, it's going to be harder to actually tell the AI what to do. You have to really know your robotic arm or your domain knowledge. This is actually true for all the AI, not only edge AI, but also cloud AI. You need domain knowledge to tell the AI what AI should do. So let's talk about the MicroAI one-tag fields. The MicroAI is a AI built for the edge and endpoint that can live on any edge or IoT devices. MicroAI doesn't need GPU environments to train. It doesn't need a lot of computational power. It can live on MPUs and MCUs. A very key differences of MicroAI compared with all the other edge AI is that we are the only one at this moment that can train the model at the edge. You don't have to send your data to the cloud. The training can be done at the edge at the endpoint. The computational power that needed for the training is not very huge, and more importantly, our training the model is recursive. Generally, most of the AI algorithm, especially for the cloud-based, it not only needs a huge amount of computation power, but generally needs a huge amount of memory to hold all the data. Our recursive design eliminates this need. We need very tiny memory footprint to train the AI model. And it allows us to train more precise and accurate models. I'll hand it over to Chris Catterton. He'll talk more about behavioral detection capabilities and other examples of MicroAI. Thank you very much.
Thank you all attendees for joining us today. I'm Chris Catterton, Director of Solution Engineering here at OneTech. And as we've discussed through the previous slides, we have certainly seen the evolution of AI move from gigantic computers from that 1956 study into GPU-based environments, and last year MPUs were being used quite a bit for running AI. And through our research, we're involved with many different research firms. As Abraham mentioned, we have validated that MicroAI is the only offering today that can train specific models on MCUs. And really what this allows us to do is be very specific for the deployment. And a quick example of this would be for a smart water meter. Let's say that you and I are neighbors. You have a pool and a lavish landscape and have a big irrigation system. And maybe I'm that neighbor that just doesn't water quite enough, and I don't have a pool. So if we had a model that was trained in a cloud environment and then pushed down to each one of these different smart water meters, and the model would be the same if it was trained in the cloud, it would say that one of us has abnormal water usage, right? Maybe you have too much or I have too little. And so why it's important and why we keep kind of driving this point home of training at the edge is that it's specific for the individual asset. This even goes into two different examples. One, you could have the exact same make and model of a particular piece of equipment, but one may be deployed in North Dakota and one may be out in West Texas. So think of oil and gas deployment. Again, you would need to take into consideration the environmental pressures and differences to have a model trained directly there at the edge. So in doing so, whenever we train these models and switch it over from training mode to really production mode, MicroAI starts generating outputs, and some of those outputs are detecting signs of failure. So we look at how the various components that we're monitoring are performing and how they're trending, and we can predict when a particular failure would occur. And this is through thresholds that are set through the AI model. So being able to give a forewarning of a potential sign of failure, automatically open up a work order for that particular asset, certainly allows for less unexpected downtime. And we do this by tying in sensor values, right? So your standard gyroscopic accelerometer, temperature, humidity. We're doing a lot with acoustic emission. So think of little microphones that are listening to bearings and various frequencies. So we aggregate those. We can also pull in data that is existing on these assets. So whether it's pre-embedded on the asset from the manufacturer, it could be PLC related data. It could be other IT systems that have information based on these individual assets. We can aggregate this, push it into MicroAI, process that data, and then send out these alerts and notifications. On a separate offering, since MicroAI is a multi-dimensional behavior analysis machine learning algorithm, we're able to not only look at those physical sensor values or environmental sensor values, but we can look inside to the IT asset, right? So these connected assets. So again, instead of the physical sensors, we could look at those internal components, think of CPU usage, or maybe it's data packet frequency or size, the endpoint, where is this data pointed to go? So, many devices, especially IoT devices, have a pretty common and regular cadence of how they transmit data. It may wake up every hour and send an 8 KB packet to a certain destination, and it, runs that course over, many, many months or multiple years. If all of a sudden that device starts sending a 64 KB packet every second or every 30 seconds, that would certainly be an anomaly. Or if the endpoint is changed, and for example, there was a big DDoS attack where IP cameras were hacked a few years ago, and the traffic was pointed to, I think it was Twitter and Netflix servers, and brought down those two offerings. That whenever that endpoint was changed, destination IP was changed, that would have been picked up as an anomaly. And so whenever those anomalies are detected, MicroAI can trigger action. And so specifically for that use case that I mentioned with those IP cameras, we could have triggered that network traffic to be cut to those devices whenever that anomaly was detected. It could be that we trigger a command for that device to reset or reboot back to its stock settings. So a couple of different ways to take action, both on predictive maintenance side of the house, predicting signs of failure of these physical assets, and then also on the security side. These can run in tandem with each other for these deployments. Another aspect is that since we don't have to send data up into a cloud for training, as in previous years of how AI models have been formed, we train there at the edge. We're able to keep this data private, and this is especially important for a lot of tier ones. We work with a very large tier one automotive manufacturer, and they actually want data to stay private from plant to plant. So the ability to form these models in that local environment is certainly a benefit. So what this does, it improves your asset performance management, right? So you have better insight to how the assets are performing. It doesn't have to be a robotic arm on on a factory floor. It could be looking at how a gateway is performing that's deployed in a customer environment. It could be how network infrastructure is performing out in the field. And what this does is, by generating that insight, creating that automated response and kind of forewarning of potential signs of failure, you improve your OEE, so overall equipment effectiveness. which of course has a long list of additional benefits. If your machines and assets stay up and running, then of course that has many benefits that hit the bottom line for a business. So this is really a convergence of IT and OT, right? So you have your operational technology, those assets that are making everything run with inside of facilities, along with the IT assets, really bringing them together to work hand in hand. So we'll quickly look at the right-hand side of the screen here, MicroAI. So in the center, right, so we're connecting to these assets, we're aggregating that data. Really three key layers to MicroAI. One is sensor fusion, right, bringing all these different data points together. Second layer is the engine, right? That's where we would train. After the training, you would then switch over to production mode. And that last layer is what you do with the output. Right, so do we need to call an API? Do we need to send a SMS or a push notification? Do we need to open up a work order, etc.? And this data can be sent to some applications that we have here at OneTech. So one is a mobile application, and this is built specifically for the guys out in the field who need to actually go service these assets. So think of if an asset is showing signs of failure, I may go ahead and put something on a calendar for a couple weeks out along this person's route for them to service that asset. If it's a critical alarm, they would get that push notification come through to the mobile app, and they're able to go into that asset, look at the data signature that caused that critical alarm. They can see previous logs, maybe it's notes, videos, any notifications that have come from this particular asset. And a second element of this is the ability to classify these alarms. So at the very root of MicroAI, again, it's looking for those anomalies. But taking that a step further, whenever we do take that data snapshot, the technician or user of that mobile app can go to that asset, see that it caused a critical alarm, and maybe, let's say it was a robotic arm that that he's servicing. He could say, okay, robotic arm was obstructed. So next time we see that data signature, we can then classify and give more detail to that alarm that's coming through. And then on the right-hand side, we have the desktop application. So this is built to either run in a cloud environment or on-premise. And really a couple of different key elements here. One is work order management and dispatch management. So typically, the customers that we're working with already have work order management tools. But if they don't, there is the ability to utilize what we have for work order and dispatch management. Further than that is the visualization and the ability to run further analytics on this data. So think of an enterprise asset management view. So, could be in the telco space where you have assets all across the globe. Could be in the manufacturing setting where I have various facilities and plants across the globe. And I start at that very high level and only see the items that actually need my attention immediately. This is caused through, how we do this is through various alarms and notifications that pop up on the screen. Color coding, etc. And then you're able to drill down into subsequent layers in whether that be regions or particular facilities, into a particular line, station, individual assets, and then those components that make up the individual asset. So many different layers that you're able to drill down into with that visualization. Other point with inside this desktop application is the ability to run those further analytics. So is it a particular make and model of asset that's causing the most unexpected downtime or the most issues? Is it within a certain time period of being maintained? You can run analysis on, is it between certain shifts? So shift 1 runs fine, shift 2 always has a bunch of issues. So point of this is the ability to run further analysis with inside of this desktop application. As mentioned earlier, right, so we can connect into those existing IT systems, and we can also deploy this these applications, right, separate from MicroAI, the visualization, the work order management that can live in any cloud, right, agnostic to the cloud, AWS, Azure, customer server environments, etc. And I think we mentioned this at the top of the call, but if you guys have any questions, feel free to drop it into the chat and we'll address those here momentarily. So we'll walk through two separate use cases, right? So an OEM, or the owner, that asset owner of the equipment produced by the OEM, has little insight to how that machine is actually performing, how it's being utilized, just overall little insight to that equipment. So what we do, we bring in MicroAI, we connect to that asset, whether we live directly on that asset or go over the top by deploying an MCU or an MPU directly to connect to that asset, aggregate those various sources of data, add additional sensors if needed to get that 360-degree view of the asset, aggregate that into MicroAI, process it, train the model, and then switch it over to production mode. This would then trigger that output for creating those events and alerts for action to take place. Second use case, as mentioned earlier, is really endpoint security. Again, looking internal to those assets and making sure that there are no anomalies happening inside of that IT connected asset or internet connected asset, and triggering action based on any malicious intent or threats that we detect through that process. So I know we covered quite a bit here. This is really a summary of what we've covered, right? So here at OneTech, with our product MicroAI, we're enabling Edge AI and really specifically endpoint AI, with now being able to successfully run in MCU environments. I think it gets confused or it's rather ambiguous what the edge is. So we're starting to kind of classify, at least internally, Edge is more of your gateways, your modems, your routers, and those endpoints that are talking to that edge router or gateway is what we're classifying as endpoints, right? So now we're able to run endpoint AI to understand how those assets are performing, along with providing that extra layer of security and privacy, since that data, only processed data, needs to leave that environment. Again, able to train, deploy, live there directly at that network endpoint. Again, this is, at the end of the day, people buy solutions for the business value, right? So it's reducing those catastrophic failures, it's reducing unexpected downtime, giving you forewarning of those signs of failures to take action upon whenever they're detected. And the AI can can be set to send the alerts, the notifications, but if need be, and you want to have a snapshot of raw data on a certain frequency, or maybe you want maximum, minimum values over a certain frequency, that can also be configured inside of the tool as well. And with that, I'll open up the floor for Q&A, and I see that there's been a handful of questions coming in here. One question, so different environments that we are running MicroAI in today. So early days, we were running primarily in microprocessors, right? So think of your Raspberry Pi type of environments. Over the course of the past 9 months or so, we have shrunk down the footprint, as Abraham mentioned earlier, and can live in those MCU environments. So started in MPUs, have now moved to MCUs. There's a handful of different flavors of MicroAI, if you will. We have a version in C, which is for these MCU-based devices. There's also Python versions as well. Are you able to perform training at the edge also, or only on cloud platform? So training, yeah. So that's really the key differentiator here is training specifically and directly there at the edge, at that endpoint. So that is what we are geared to do is train directly there at the network edge.
Right, so it looks like we got one more that came in asking what the exact pricing model is specific to MicroAI.
Yeah, so we're working with kind of two different sets of users here or buyers. We're working a lot with silicon manufacturers in embedding MicroAI into their hardware as it's being produced. So that's more of a kind of bulk license type of pricing model. And then, of course, as mentioned earlier, we're working directly with those end users, such as the manufacturing facilities, some oil and gas firms, some agriculture firms as well, in the fertilizer space. And those are, again, it's a license model, and we call that Helio server licenses, where we are providing, the visualization, the workflow management, along with MicroAI for those embedded sensors and for their equipment. We're working with multiple partners, as I think probably everyone in this call knows. These deployments take many different people to create the full solution, right? So you need need the software, obviously you need the hardware as well, and then you also need that network communication protocol partner. So through working with those partners, we typically try to package that full end-to-end solution so that our end users, our clients, don't have to source this individually and just deliver that kind of turnkey solution. So two different paths, one with the hardware manufacturers, the smart device manufacturers, more of a bulk license deal, and then with those end users, more of a server license with professional service hours on top of that.
Okay.
All right.
Well, I think that is it for the questions. So
wonderful.
Again, if
and with
you
that,
have any
we
questions
thank you
that
all for joining us.
come up after this webinar, I'm sure you've seen the reminder emails coming in. There'll be a follow-up email with the recording of this session sent out, and within there, my direct email is at the bottom of that email. So feel free to respond directly back to me if you have any additional questions that you'd like answered, and I'll be sure to get you in contact with the right people who can help you. And
this is the start of our webinar series here at OneTech. So thanks for being a part of this webinar. Future webinars will be much more deeper dives into the AI algorithms, how they work, how we form them. So we'll keep you posted. That date is not set. We're looking here probably in the next 6 weeks or so, kind of finalizing the material for that. So everyone that registered for this, you're on a list, and I promise we're not going to hit you with a bunch of sales related inquiries, but we may reach out to let you know when that next webinar is, and just to touch base to see if there is any additional information that we can provide. So to stay tuned for additional webinars. And again, thank you all for joining today. Hope everyone has a wonderful rest of their day and a wonderful week.
everyone.